Okay, so in question 3c, we are now talking about a valve network. And this valve network consists of 15 valves. And we are told that the network fails if, network fails if 13 or more valves fail. And what are we trying to find here? Determine the probability of the valve network failing. So what we want to find is the probability that the network fails. So the first thing I notice is this is equal to the network fails if 13 or more valves or individual valves fail. Okay. So the random variable of interest here seems to be discrete. Okay. Each valve can either fail or not fail. Okay. And the probability of 13 or more out of 15 failing seems to follow a binomial distribution. Okay. So what I'm interested in here is for any given valve, okay, so let's say I have a valve here, what is the probability that it will fail and what is the probability that it will not fail? The probability of a particular valve failing, okay, is the probability that X does not last X hours. Okay. And the probability of not failing is the probability that obviously time until failure is greater than X. And we're actually told that this is equal to 30% because what is this? That is the reliability. Again, reliability or the probability that the valve lasts at least X hours, which makes the probability of a valve failing the complement of its reliability, or 70%. Okay. So going back to my original probability here, okay, let's continue that here. Let's continue here. Is going to be the probability that y is greater than or equal to 13, where y is now binomial with 15 Bernoulli trials and a probability of success, where here success is defined as failure, right? 70%. We want to know the number of failures out of 15 trials. So the network fails when either 13 of the valves fail, or 14 fail, or 15 fail. And each of these guys have a binomial distribution. Once you have it up to here, the rest is really mere computation. Plug it into the binomial formula. So we get 15, choose 13. 0.7 to the power of 13, 0.3 to the power of 2, plus 15, choose 14, 0.7 to the power of 14, and 0.3 to the power of 1, and finally 15, choose 15, all of them failing, 0.7 to the power of 15, 0.3 to the power of 0. Okay, compute all of this and you should get 12.68%. Okay. So the failure, this is the failure probability of the valve network. Of the network. But if I take the complement of this, okay, if I take the complement of 12.68%, that is equal to 87.32%. And that right there in itself is also a reliability measure. It's the reliability of the valve network. Okay. But the answer to the question and the answer we're looking for is 12.68%.